Hello, guys. Okay, so this is DNA mutations part 2. So if you did not watch part 1, stop, go back and watch part 1 first, and then watch this one because this is the second half. All right, so let's quickly just briefly talk about what we say that again. Let me briefly review what we just learned from part 1. And that will lead us right into part 2. So if you remember, we're talking about genetic and chromosomal mutations. In part 1, we specifically focused on genetic mutations. We talked about what mutations were, like what are they? We talked about what cause mutations. We talked about the different things that can cause it, the mutagens. And then we got to the types of mutations. So in part 1, we specifically looked at things like deletion, translocation, inversion, duplication. In this video, we're going to specifically focus on missing chromosomes and extra chromosomes. That's what we're going to be focusing on in this one. So let me scroll on down. Okay. So when we're talking about missing genetic information, specifically, we're talking about something called non-disjunction, okay? Non-disjunction. Let's break down this word, okay? Because this is it's kind of all crazy, right? So let's do, so first of all, let's do junction. If you think about the word junction, junction is where two things meet, okay? So two things come together. So like the junction of two roads is where they cross. That's a junction, okay? Disjunction means that they don't come together, okay? They're not together. So disjunction is the opposite of junction, okay? So disjunction means they're not gonna come together, they're not staying together, they're gonna separate, okay? Non-disjunction means that they didn't separate. They're back together. I know what you're thinking. Okay, Ms. Agid, if non-disjunction means that they stay together, why don't they just say that it's junction? Well, that's because in the process of meiosis, disjunction has to happen. What? Remember we talked about meiosis? Remember we talked about how the cell has to divide, okay? Remember we said how meiosis happens only in the sex cells, okay? So we said mitosis happens in what they call the somatic cells. Somatic cells are all the cells in your body, skin cells, hair cells, heart cells, muscle, bone. All of those cells undergo mitosis, okay? In your sex cells, sperm, egg, meiosis takes place, and we talked about that. Remember, we also said that the reason why meiosis happens in our sex cells is because we're trying to make a baby, okay? We have 46 chromosomes. I get 23 from mom, 23 from dad. The reason why I get 23 is because of disjunction, okay? So when the cell is dividing in the process of meiosis, we want to disjunction, we want to separate the chromosomes so that my sperm only has 23 chromosomes and my egg only has 23. So I have to break them up. They need to disjunction, they need to separate so that I only have half the information. Well, what happens when they don't separate? That's non-disjunction. Non-disjunction can happen during different times of the meiosis process. If you guys remember, there are two phases, right? Meiosis, it was inter, pro 1, meta 1, ana 1, telo 1. Then it was pro 2, ana 2, meta 2, telo 2. Okay, so depending on where the non-disjunction occurs will determine what happens with the cell. So let's go through the first one here. Look at this one here. So here is my homologous chromosomes. This is meiosis 1, okay? This is normal. There is a division here, you see? Now, this chromosome is supposed to split in half. You see how it's an X? I have half of it here half of it here, that's good. This is disjunction. It separated. Yay! But look here. You see the X? The X did not separate. Non-disjunction. So the X, both sides of the chromosome, went into one egg, and this chromosome doesn't have that. Now, let me clarify this. This is not telling you that the egg is empty. No. All it's saying is that this one particular chromosome is not in here. So instead of this chromosome having 23 chromosomes, it only has 22 because it's missing the chromosome that went into here. So this one has 22 chromosomes. On the flip side, this one's supposed to have 23, right? But it has an extra one. So it actually has 24. So this egg has 24 chromosomes. This egg has 22 chromosomes. Now here comes the sperm. Let's say the sperm is normal, okay? So in the first two scenarios, the baby comes out fine. You see where it says 2N? 2N, that means that it has 2 times the number of 23 or 46 chromosomes. So normal, but look what happened here. Because the egg had an extra chromosome, the dad was normal, it has 23 plus 1. Excuse me, let's try that again. It has 46 plus 1 or 46 chromosomes. Look at this one. It's a minus 1. So it was supposed to be 46, but only has 45. So this baby has 45 chromosomes. This baby has 47 chromosomes. What else could happen? Look here. What happens if the non-disjunction happens early? What if the non-disjunction happens up here during meiosis 1? So instead of the first pair breaking in half like this, the homologous chromosomes breaking in half, they don't. The homologous chromosomes stayed the same. So all the genetic information for that chromosome went here, and none of it went here. Look what happened. Look what happened. So now in this scenario, notice that all of the offspring are going to have an issue. In this scenario, there's a 50-50 chance that the baby is going to be normal. Because remember, it's only one sperm, one egg. Remember, it's probability. So there's a chance that maybe the baby might be one of these two. But it could be one of these. In this scenario, no matter what happens, the child's going to have what they call a chromosome mutation. It's a mutation in the number of chromosomes. That's why it's chromosomal. So these babies here both have 46, 46. These babies here both have 45, 45. So no matter what happens, this baby, because there's only going to be one of them, right? No matter which one it is, the child's going to have a chromosomal mutation, okay? So chromosomal mutations result in either too many or too few chromosomes. Does that make sense? I hope so. Let's see what this results in. The most common chromosomal mutation out there is Down syndrome. And I say that because Down syndrome, like I said, is the most common. Most people may even know someone that has Down syndrome. So common. Down syndrome is what they call a non-disjunction of chromosome 21. So this here, guys, this is called a karyotype. You guys are going to learn later on in the video how to create and how to read a karyotype. A karyotype, guys, this is what they do when moms are pregnant and they want to find out if it's a boy or a girl, and they want to see if there's some sort of genetic mutation. They'll take the blood of the mother, or they can take the embryonic fluid, which is probably more common. That's the fluid around the baby when the mom's pregnant. You know how the baby's floating in some liquid? Okay, that liquid that the baby's floating in is called embryonic fluid. That fluid contains cells from the baby. So they can use that fluid, and what they'll do is they'll literally put the chromosomes of the baby on a screen. It looks like this, okay? So remember, 46 chromosomes, 23 pairs. So if you count this, there are 23 pairs, 46 total. But you see here, you see how there's 3 of them? This is the non-disjunction. So either the sperm or the egg. Now, I know my last image showed the egg having the problem, but it can happen in sperm, okay? One of them had a non-disjunction. So the baby has 3 copies of the 21st chromosome. You're only supposed to have 2, not 3. Hence, this child has a non-disjunction of chromosome 21, and that results in what we call Down syndrome. The reading of karyotypes, guys, is very, very important. This is how, again, cytogeneticists, this is how they analyze the genetic information of a child to determine what they call gross genetic changes. The word gross does not mean gross. No, the word gross means that it's significant, it's big. If you remember in part 1, we talked about genetic mutations, changes in the actual code, okay? So what we did in part 1 was changes in the code. It was changes in the nitrogen bases. Those are small genetic changes because it's happening at the letter. So those are really little changes. This is what we call a gross genetic change because it's a change in the entire chromosome. So that's huge. So they use the word gross because it's bigger. That's what it just means. It's a bigger defect. It's so big that you can see it on a karyotype. Point mutations, inversions, all those things are hard to see on a karyotype because you're talking about a nitrogen base that's really tiny. This type, non-disjunction, is such a huge change that you can see it on a karyotype. All right, so how do I read a karyotype? Well, here is a normal female karyotype. So first thing I want you to notice is the way it's set up. All karyotypes have a similar setup. Notice that you have it numbered 1 to 5, 6 to 12, 13 to 18, 19 to 22, and then you have an X and a Y. All right. These are the sets of chromosomes. Again, go back. We have 46 chromosomes or 23 pairs. If you count each individual chromosome, there's 46. But again, we get 25 from mom, 25 from dad. So what you do is you match them up. Notice how they're matched up by the length. Notice that the chromosomes at the top are longer, they're bigger in size. As you go down to the 22nd, notice how they're much smaller. Each one of these chromosomes, what you're looking at is your DNA coiled really tight so that I can actually see the letter X. If I unravel this, remember we talked about how we said the genetic information in one cell would be like 6 feet tall? Okay, so if you were to take all these X's and unravel them and put them tip to tip, that's when you would get 6 feet tall or 6 feet of genetic information. Okay, so this is coiled DNA. We match them by the length, so they all match in length. Okay, notice that when you get down here, this is your 23rd chromosome. Usually they don't put the number 23. Instead, they give you the sex. So they have an X position and a Y position. If there are 2 X's like this one, you'll see 2 X's. Notice that there's nothing above the Y because this is a girl. Girls don't have a Y chromosome, okay? You have 2 X's, there's nothing above the Y, this is a girl. Let's look at this one. Okay, this is a normal male. Notice the similarities. 1 to 5, 6 to 12, 13 to 18, 19 to 22, and then there's my X and Y. But do you see the difference here? You see how my X is really long and they have a little short thing here? That's the Y. I hate to break it to you guys, but that's it. Yeah, this is what makes you a guy. You know, it's so funny. Over the years, every time I would show the difference between the male and female karyotypes, my boys in the class would always start laughing because they would say, oh, now we know why girls are so complicated Because if you look, remember with the girl, there were 2 big X's, but with the guy, it's just a little OY here. So girls, there's like so much more information that makes us ladies than there is that makes a guy. So I remember my students always talking about, oh, girls are just so complicated. They need more information, versus a guy, but that's it. So that's how you can identify what a Y is. The Y chromosome is very small in comparison to the X. And this is what makes you you, okay? What you're looking at is all the genetic code that made you, you. So now, okay, so now how do I read these things? All right, so the way you read is very simple. Numero uno, figure out how many chromosomes are there. Every number must have 2 chromosomes because again, we got one from mom, one from dad. So when you're diagnosing karyotypes, you want to look and make sure that every number has 2 chromosomes. So you can just glance, this one does not have 2, this one has 3. Now, I already know that normal is 46 chromosomes. That's a known. I don't have to count every single chromosome because I know there's 46. That's the norm. But this child it doesn't have a normal chromosome. It has 1 extra, see? So 46 plus 1 is 47. So the first thing I'm going to write is 47. 47 is telling me how many chromosomes there are in this child. There's 47 chromosomes. Next, identify the sex of the organism. So I got to go to the 23rd chromosome, and here it is. Most karyotypes will put the X before the Y. For some reason, this one did it, but it doesn't matter because you always write it the same way. It's always the X before the Y if it's a boy. If it's a girl, then it'd be XX. In this particular case, I see an X, you see the line here, and I see a Y. So I know that this is a boy. I put XY here. Even though I know it's in reverse, you always write the X first. That's just how they write it. Next one. If an error has occurred, you need to indicate that error in the 3rd position. You use a plus sign for an extra chromosome, or you use a minus sign for a missing chromosome. In this particular case, this child has an extra 23rd chromosome. So I put a plus because it's extra. I put 21 because it occurred at the 21st chromosome. It didn't happen at number 3. It's not at 7. It's not at 17. No, it's at 21. Hence, it's plus 21. So the diagnosis for this karyotype is 47, XY, plus 21. Let's try another one. All right. Step 1. How many chromosomes do you see? Just glance. Does every number have 2? 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 Oh, wait a minute. This one doesn't have 2. Remember, your 23rd chromosome still has to have 2, guys. You got to have 2, okay? You got to have 2 of everything. Over here, I only have an X. 1 X. I don't see 2 X's, and I don't see a Y. This child is missing a chromosome. Okay, if 46 is the normal, I'm going to subtract 1 from 46. 46 minus 1 is 45. That would be my first number here. So this will be 45. Well, where's the mistake? The baby is missing a chromosome, so I'm going to put a minus sign. Which number is missing? Chromosome 23. Now you might be thinking, oh, Ms. O'Gean, it doesn't say 23. You're right. It usually doesn't say 23, but I know it's a 23 chromosome because this one says 22, right? What comes after 22? 23. The 23 chromosome is always your sex cells. It's always your sex chromosomes. So I'm going to put a minus 23 here because it's missing the 23rd chromosome. I'm sorry, I read that wrong. Sorry. And this I'm going to put an X, and I'm going to put a minus 23rd here. Let me say that again. So here is going to be 45. Here, I'm going to write the sex of the child, excuse me. The sex of the child is number 2. I did that wrong. Sex of the child is 20 is the second one. I'm going to put an X here because it only has one X. There's not 2 X's. I don't see an XY. So I have an X here. And then here is going to be minus 23. So 45, the letter X, minus 23. 45, because there's 45 chromosomes. The letter X, because there's only one X that's visible. That's the sex of the child. It is a girl, but she only has one X. She doesn't have 2 X's. So it is a girl. And it's minus 23 because it's missing one of the 23 chromosomes. Okay? By the way, you got to have a Y to be a boy. So if a child only has one X, it's still a girl. So this is your answer, 45X minus 23. That's your diagnosis. It is a girl, but it's just missing a chromosome. All right, let's try another one. All right, look at this one. Numero uno, how many chromosomes do you see? Check every line. Did you find the error? Pause the camera or pause the video if you need to. All right, I found the error. Did you see it? It's right here. Here's the error. You're only supposed to have 2 chromosomes. I see 1, 2, 3. That's too many. Remember, guys, the X and the Y together, that's your 23rd chromosome. You're only supposed to have 2. You either have an X and an X or an X and a Y. This child has an X, X, and a Y. That's too much. So it has 1 extra. So 1 plus 46 is how much? Write that number. Do the sex of the child. What are the letters that this child has? I see 2 X's and I see a Y. Put that in the middle. What is the error? The child has an extra chromosome. So what symbol will you use for extra? And what number has the extra chromosome? Put that on the 3rd line. Okay, let's see if you got it right. Did you get it right? 47XXY plus 23. All right, try this one. Again, look at every line. Did you find an error? Okay, if you did, give me the number of chromosomes this child has. Put that on the 1st line. Look at the 23rd chromosome and tell me the sex of the child. Now tell me what the error was. Is it an extra chromosome? Put a plus. If it's missing a chromosome, put a minus. And what number has the error? Did you get it? If you need more time, pause the camera. Pause the video, excuse me. Did you get the right answer? Did you find it? It was number 16. 1, 2, 3 chromosomes, that's too many. It is a boy, because he has an X and a Y. It is a boy, but it's a 47. It has what they call, trisomy 16, but it's three number 16s. Okay, I think I have another one. No, okay. So we did, these are some non-disjunctions that can happen within a single chromosome. What happens if it's the entire chromosome? So what we just looked at, these types of things are often called things like trisomies and monosomies. And in an assignment you guys are gonna be doing a little bit later, I'll explain a little bit more about that. But when you have 3 of a chromosome or 1 of a chromosome, sometimes they call it trisomies. So like for instance, this would be considered a trisomy 16 because they have 3 tri of the 16. So trisomy 16. This one would be called a trisomy 23 because you have 3 23s. This one is called a, what is this one? This is a monosomy 23, mono meaning 1, because it only has 1 chromosome. So it'll be monosomy 23, because it only has 1 23. Okay. And then I believe these are normal. This one was, yeah, this one was this one normal? No, this is a trisomy 21, excuse me. See, he has 321, trisomy 21. Down syndrome is the common name, but the medical name is called trisomy 21 because it's 321s. And then obviously when it's normal, then it's just normal. But that's when you have a single chromosome that's either too much or too little. What happens in this scenario? So what happens if you have a non-disjunction that happens and all the chromosomes are carried over? So we have our diploid cell. This is normal, okay? Let's say that in the development of the sperm and the egg, the non-disjunction didn't just happen at one chromosome. Like it didn't just happen at chromosome 16. It didn't just happen at chromosome 21. Like the entire thing did not break apart. So in other words, you have an egg that has all the chromosomes and you have eggs that don't have enough whatsoever. That's what you call ploidy. You can have something called a monoploidy. A monoploidy means that, and I'm going to go back to this picture here. A monoploidy means that when the egg or the sperm was developing through meiosis, the non-disjunction happened with all chromosomes, all of them. So when we get here, these eggs literally have 46 chromosomes in it. And these eggs actually have nothing. It's literally like just a shell. It's very rare, but it can happen. When that happens, when either the egg or the sperm doesn't have any chromosomes in it whatsoever, because of a non-disjunction that happened for the entire set, you end up with a child that only has 23 chromosomes. It's called a monoploidy. They only have 23 chromosomes. They only have one set of information. If that occurs, this child is usually what they call spontaneously aborted. A spontaneous abortion means a miscarriage. If this happens, the mother will probably never even know she was pregnant. This can happen, and it probably happens more often than we even realize, because this child will not develop. The way nature works, you can live with too much information, but you can't live with too few. And if you think about it, that makes sense. I mean, think about it. If you order a desk from Amazon, and Amazon sends you the box with the parts, and let's say that in the box you're missing, you know, the tabletop, the top of your desk, you know, the part you write on. Let's say that part is missing. Can you build a desk? No, because you need that part, right? You can't build a desk if you don't have a top. What are you gonna write on? That's not a desk, right? That's not a desk. So you can't make a desk if you don't have all the parts. Now, let's say Amazon sends you that desk, but they sent you an extra leg. So instead of having 4 legs on your desk, you have 5 legs. Can you still build your desk? Well, yeah, you can build your desk. I mean, you got an extra part, but you can still build the desk. So likewise with human beings, if we have too much information, that is a genetic error, and things do happen. We know that, but you can still make a person, because you have all the instructions on how to build the person. So you can still make a child. But if you don't have enough information, that's like the desk without the top. You can't build a human if you don't have all the parts. So hence, monoploidy babies are miscarried. They do not go full term. They won't probably even make it beyond the first 3 months. Maybe you've heard, maybe you know of someone that has experienced a miscarriage between the first 3 months, or what they call the first trimester. When a child is miscarried during the first 3 months, if there's no extraneous circumstance, I mean, like there wasn't something physical happening to the mother, you know, if the mother's doing everything to the best of her ability, the right way, and she still miscarries the first 3 months, within the first 3 months, usually it's because of some sort of what they call gross error. In other words, when the child is being developed and the cell is reading the code, if there's too many errors, The body's like, wait a minute, we can't build this baby. There's too many errors. Get rid of it. And it aborts. It miscarriage. This is an example of where the cell will start to read the code and say, wait a minute, we don't have enough information. This isn't right. Okay, we can't build this child. We're going to remove the child, hence the miscarriage. What happened? That's a monoploidy. Down here's what they call polyploidy. This is the other way around. This is where, let's say, the egg or the sperm has a full set of chromosomes. So let's say the sperm has 46 chromosomes and the egg has 23. So you do the math, guys. 46 plus 23. That's a whole lot of chromosomes, right? That's what they call triploidy. These babies, and I'll show you a picture of one in a second. They don't always, they usually don't live. Usually they don't. This is way too much information. It's like information overload. Okay. That would be like, you know, Amazon sending you that kit and you got like 4, 5, 6 pieces of everything. And it's just like this big hot mess. I mean, you just got too much stuff. It's way too much stuff. That's what this is. So these children usually do not live. They usually are miscarried. You can have what they call triploidy or tetraploidy. Tetraploidy is both the egg and the sperm had too much information. It was 46 and 46. What's 46 and 46? That's what? 96 chromosomes. That's a lot of information. Way, way too much. So in that situation, it's just way too much information overload. And the child usually doesn't live. This here is an example of a triploid, what they call triploid syndrome. This baby was delivered, but did not live very long. If they make it, if they are born, they usually die within the first year of life. The baby's so cute. This baby is called triploidy. So either the egg or the sperm had a full set of chromosomes, had 46, and then the other one had 23. So you see how the baby has 3 of everything? So the body was able to create the child, but it's just too much information and it can't handle that. Hence, the majority of triploidy babies are usually miscarried. If they make it, they'll die within the first year because you just can't live with this. This is like information overload. 69 chromosomes. That's a lot of information. It's just way too much. Way, way, way too much. And so, you know, that's what happens there. This one here is a tetraploidy. Now, this child did not make it, but they probably, my guess is they probably did like an embryonic embryocentesis. They probably was looking at the embryonic fluid of the baby to get this. But yeah, there's 4 of everything. You see that? That's a triploidy. That is a baby that was conceived with an egg that had 46 chromosomes and a sperm that had 46 chromosomes. And you see the diagnosis, look how the diagnosis looks down here. Yeah, but it was a girl. See that all X's? So it definitely was a girl. But it has 4, it's just information overload. So this baby was definitely most likely miscarried. I'm sure did not go full term. It's just information overload. So the way we are designed, we can only live with a limited amount of extra information. We can live with extra, but it can't be a lot. It just can't be. Because if it's way too much, it just can't handle it. You definitely can live with too little, but you can live with a little bit too much. Okay, so let's take a look now at, okay, so I think that's, oh yeah, so we're done. All right, so we are finished reading our karyotypes. Here is one more, let's see, for you guys to try to diagnose. Okay. So first of all, what would you name this mutation? And what would the diagnosis be? As you probably guessed, this is considered a non-disjunction. It's a non-disjunction because at 18, it did not break up. You see that? So the diagnosis for this would be what? Did you figure it out? Did you get 47? XY plus 18. That would be the answer to this one. Okay. All right, so now let's do our assignment for, this is going to be DNA mutation assignment number 2 on karyotype. So get your paper, get your pencil, get a pencil, and let's get ready. We are going to create a karyotype. All right, so let me switch my camera. And let me fix my camera so you guys can see. There we go. Oh, did I get it? Yes, I did. All right, so this is gonna be assignment number 2, DNA mutation. This is gonna be karyotype. So let's call this, we're gonna call this creating. Whoops, should be creating karyotype. That's supposed to be an I there. Creating karyotypes. This is going to be assignment number 2. All right, numero uno. First things first, let's set up our karyotype. You must write it the correct way. So let's number this. 1, 2, 3, 4, 5 is always the first row. Second row, we're going to go 6 to 12. Give yourself some space because we're going to draw in our chromosomes in a second. So I'm going to do 6, 7, 8, 9, 10, 11, and then 12. Okay. Next, third row, 13 to 18. 13, 14, 15, 16, 17, 18. Last row, 19 to 21, and then X and Y. 19, 20, 21. I think my, okay, I think my headset is about to die. Yep, they are. Okay, I'm gonna switch my sound. Give me 1 second. Let me just pause for a minute. All righty, so hopefully my sound sounds good. I had to switch my headset. So 22, and then I'm gonna put an X and then a Y. All right, so I'm gonna tell you what type of thing we're going to create here. So what we're going to do is we're going to create a karyotype that shows, let's say a trisomy 13. Okay, so we're going to aim for a trisomy 13. So what does that mean? So I'm going to put 2 chromosomes for everything except for the number 13. So put your, get your X's, make sure your X's at the number 1 are a lot taller. Try to keep them about the same length. As you go down, try to make them a little bit smaller. I am creating homologous chromosomes. And as I go down each row, they are going to get shorter. My trisomy 13, trisomy means 3. So give yourself 3 chromosomes here. And then everything else should be 2s. Make them a lot smaller when you get down here. All right. So let's see, do you want it to be a boy or a girl? How do we make it a boy? Okay, so to make it a boy, I'm gonna put an X for that, and the Y is like a little wiggly line. Okay, there you go. So this is the boy. Now let's write out the diagnosis. So the number, there are 47 chromosomes. How do I know? Because every number has 2 except for number 13. So it's 1 extra. 46 plus 1 is 47. It is a boy because I gave it an X and I gave it a Y. And it's a trisomy 13. So there's an extra 13. So I'm going to put a plus and I'm going to put a 13. And that's my diagnosis. The name for this is trisomy 13. There is an alternative name for it, which you guys will be talking about later, but it's a general name for trisomy 13. All right, let's get ready to do number 2. Do your setup again. Go ahead and number it from 1 all the way down to the X and the Y. Go ahead and set up your number down here, and then I will tell you what your karyotype is going to be. Okay, so you should have set yours up. Try not to make a mistake like me. Make sure your X and Y is further apart.
Okay, guys, so I want you guys to create a karyotype that shows a that shows a monosomy, we'll say monosomy 23. This is going to be a boy. Let me say that again. We're going to make a monosomy 23, and it's going to be a boy. Can you figure out what that karyotype is going to look like? Go ahead and pause it, create it, and let's see if you get it right. Again, monosomy 23, and I want it to be a boy. Okay, guys, did you figure out? Monosomy 23 means that mono means one. 23 is down here. So it's going to be one of these, and it's a boy. So this is a boy. It must be the Y. So monosomy 23 would look like this. There would be nothing above the X, and you would just have the Y. Ignore my error there. So it'd be nothing above the X and just your little Y here. And to write it out, oh man, I'm running out of room to squeeze. I'm going to squeeze it down here. So 45 chromosomes. It is a boy, so I have a Y. There's no X. It's a minus 23, and I can call this monosomy 23. Mono meaning one. So it's one of the 23rd chromosome. So, and it's missing a 23rd. So there you go. All right, ready for number 3? Here we go. Let's do number 3. Let me flip over my paper here. All right, so number it just like before. Do your 1 to 23, and then I'm going to tell you what you're drawing. Okay, guys, so you set it up. Are you ready? This time you're going to create a trisomy 23 that's also a boy. Ooh, how do we do that one? Trisomy 23, that's a boy. All right, so pause the camera, create your karyotype, and see if you got it right. Go ahead and pause it. So did you guys figure it out? If it's a boy, it has to have a Y. And we're going to have it like this. Now, to be fair, guys, to be fair, a trisomy 23, that's a boy, could be an XXY, or it could be an XYY. So I guess I wasn't being truly fair with you guys on this one. But in this particular case, it's going to be XXY. So go ahead and do your diagnosis. So you should have gotten, what was your answer? Did you get 47? XXY plus 23. So yeah, trisomy 23 could actually be this, or it could be one X and two Y's, where it would be 47XYY plus 23. Okay, that would still be considered trisomy 23. The difference is that this is an XYY versus an XXY. So it could be either way. So let's do one more like this, and then we're going to diagnose some more karyotypes because we're not quite done. Number 4 is our last one we're going to draw. Go ahead and do your setup one more time. Okie dokie. So you ready? So this time we are going to do a monosomy. We'll do a monosomy. How about, I don't know, we'll do a monosomy 12. How's that? And we're going to say that this is a girl. So if I have a girl that's a monosomy 12, what would that look like? Go ahead and create it. Pause the camera and see if you get it right. So how'd you do, guys? All right. Well, hopefully you didn't make the same mistake I made. I was writing my X's so fast that I forgot to make it a monosomy 12. So make sure you only have 1 at the number 12, not 2. Like I said, I was just on a roll. And when I got to the end, I was like, oh boy, I forgot to make it a monosomy. So only have 1 X over the 12. Go ahead and write out your diagnosis. You should have 45. It is a girl, and it'll be a minus 12. That would be the diagnosis. Monosomy 12, because only 1 here, and it has 2 X's. Remember, even though it's a girl, you still write the letter Y here. You just don't put anything above it. All right. So we're done with drawing our karyotypes, creating our own, diagnosing them. So now I'm going to give you a series of them to just diagnose. So go ahead. That's number 4. I guess we can make this number 5. I'm going to show you some images, And you guys are just gonna write out the diagnoses. So, oh, let me get another paper so you guys can't see that well. This would be number 5. Let me go ahead and switch my camera for a moment. Okay, guys, so we're going to be reading some karyotypes. We're going to be reading them, diagnosing them, and then naming the chromosomal mutation. So we're going to make this one number 5 on your paper. So go ahead and take a look at your karyotype. I want you to give me the diagnosis. Make sure you give me the sex of the child. Give me your plus or minus where the error is, and then make sure you name it as either trisomy or a monosomy. Feel free to pause it if necessary, but this is number 5. This one here is going to be number 6. Okay. Feel free to pause it as you need it, as you need to. This is number 7. This is number 8. This is number 9. This is number 10. This is number 10. This one is number 11. Number 11. This is number 12. Number 12. Number 13. Number 13. Number 14. Oh, sorry. I didn't realize I had the answer. Let me make sure no more answers pop up below this screen here. Well, that was clearly a mistake. That one snuck in there. I didn't realize I had the answer there. Well, that would have been your number 14, but this one is normal. And when it's normal, you just write it the way you see it there. Just write normal. Okay, so you should have 13 in your worksheet. You have 4. In fact, let me stop sharing for a second. Okay, so you guys have 4 karyotypes that you drew, plus you have the ones that you just diagnosed. And so that is your assignment number 1. Go ahead and take pictures. Obviously, it's gonna, I know for me, it took me 1, 2, like 3 sheets to do that on. So you may have to upload like 3 pictures of your diagram. Please make sure that I can see what you drew. If I can't see it, I'm gonna tell you to re-upload it. So please look at your photo. If you can't see it, I can't see it, okay? So once you're done with this, there is another assignment for you to do under Google Forms. So look at the list of assignments in Canvas. Make sure you do the Google Forms on, it's your worksheet, it's another worksheet on reading karyotypes. Remember, the grade you get on the Google Form worksheet is the grade I'm giving you on the worksheet. So please make sure that you do it more than once and get the grade that you like, because all I'm going to do is grab your highest score and that's it. So, you know, make sure you take your time and get an A, get an A, get an A, okay? All right, so that is the end of this video. I hope you guys enjoyed it. And one thing I do want to say before I close this out, one of the major things that I really hope you guys get out of this, out of the video lesson number 1 and video lesson number 2. One thing is this, guys, genetic mutations, be it little small mutations or huge chromosomal mutations, are things that sometimes just happen. Sometimes they are caused by things that the mother or that the father does. That does happen, we know that. However, a lot of times it just happens because things just happen. We're imperfect people. That's just what happens. So my point is this: when you see a child, a student, that's displaying a mutation, be it, like the tumor on the face or that werewolf one that we saw, a lot of times children mock them, but guys, they can't help what genetic mutation they have. I mean, a kid with leukemia is a kid with leukemia. They don't wake up in the morning and say, oh, I want to have this. It's just something that happened. So don't be that kid. Don't be the kid that mocks or make fun of somebody for something they can't change. Just like you can't change the color of your skin, you can't change your height, you can't change, there's just things like yourself you can't change. You are who you are. And you don't want someone to point it out and mock you for something you can't change. Is likewise with these kids that suffer from these various types of genetic and chromosome mutations. They can't help the way they were born. So don't be that kid. Be the kid that's their friend, the kid that's understanding. A genetic and a chromosome mutation is not contagious. Okay, you can't get Down syndrome from somebody. It's genetic. Okay, the tumors, the cancers that we're talking about, you can't get it. It's not a contagious kind of thing. So there's no reason for you to shun individuals that are like that. And unfortunately, there are a lot of people that do that. And particularly in the high school level, and I know you guys have seen it, if you're not in the in crowd, sometimes they tend to mock and make fun. So I do hope that through this lesson that it gives you a sense of empathy, a sense of, things just happen. It happened to them. It can happen to you. Your future child could have, something. It's because things like this just happen sometimes. So be the kid that's their friend. Be the kid that is understanding. Remember the things that you learned. Sometimes it's just things that happen. They can help it, but don't be the kid that mocks and makes fun. Be their friend if you know someone in that situation. So in any case, that's my little moral spill about this lesson. And so I hope it has helped you to appreciate your uniqueness, because everyone has a level of uniqueness and we all have our own little challenges, but hopefully it's helped you to appreciate a little more about you, your family, and like I said, to have a little more empathy for those that deal with these type of mutations, because sometimes things just happen. In any case, guys, that is the end of this lesson. I look forward to seeing your assignments, and until next time, I'll see you online. Ciao.